Hi guys, welcome to this page of the notes, and I'm actually really excited about this problem. One of the reasons, the law of cosines is maybe one of my favorite things in trigonometry, and it's because of the types of problems the law of cosines allows us to solve. You're going to see more word problems associated with the law of cosines than you will with the regular trig function sine, cosine, or tangent, even though lots of word problems show up, and even more so than with the law of sines. The law of cosines really applies to a lot of very interesting scenarios, including this one. So let's go ahead and take a look at what we got here. Essentially, here's what happens. We have a port. Both a patrol boat, a Coast Guard patrol boat, and a fishing boat leave the port at the exact same time. The patrol boat is traveling at 12 nautical miles or 12 knots per hour. The fishing boat is simply traveling at 5 knots per hour. Now what happens is 3 hours later, so now 3 hours later, the fishing boat has a problem. Maybe it starts sinking or taking on water, there's a fire out, whatever. Anyway, they send out a distress signal. So this is 3 hours after leaving the port. The question is, if that patrol boat receives the distress signal and heads for the fishing boat at 12 knots, 12 nautical miles per hour, how long is it going to take the patrol boat to get to the fishing boat? Of course, assuming that the fishing boat doesn't drift or anything like that. So let's go ahead and take a look at this diagram that I've given you and see if we can fix this guy up here. So here's essentially what's happening. It is now 3 hours later. So here's what I know. I want to figure out how long is it going to take the patrol boat to get to the fishing boat after it sends out the distress signal. Now let's go ahead and figure out some of this stuff as well as label our diagram, and I apologize, that line should extend all the way to the dotted line as well as this little arc up here. Okay, here's what we've got. Let me do it in a color that you can see, which will probably be black. We're going to go ahead and call this angle down here. This is going to be angle C. I don't know, hang on, you might not be able to see that. Let's do red. Alright, so this is going to be the angle C, which makes this over here side C. We'll make this up here angle A, which makes this guy down here little a. This will be angle B, which makes this guy over here little b. Alright, so there we go. We've now labeled my diagram C, side C, angle A, side A, angle B, side B. Now, let's figure out what we know. What do, I'm sorry. Perfect. Okay, here we go. Now, what do we know? Okay, here's what we know. First, I can find the measure of angle C. Look, this whole thing right here is 130 degrees. So what is the measure of the angle that is just between the direction that the two boats went, right? The whole thing is 130. What's just this little portion? Well, I'd have to take 130 minus 15. So 130 minus 15, and we wind up with the measure of angle C is equal to 115 degrees. Okay, great. So now we have the measure of angle C. Then I also will be able to find the length of B and the length of A. Here we go. A. This is the fishing boat. The fishing boat was traveling at 5 knots for 3 hours, right? It was 3 hours traveling before it ran into trouble, sent out the distress signal. 5 times 3 is 15 miles. So I know that the fishing boat is 15 miles from the port. That's A. What about B? Well, B was the patrol boat. The patrol boat's going 12 nautical miles or 12 knots, again, for 3 hours. 12 times 3 is going to be 36 miles. Okay, fantastic. So there we go. I now know the measure of angle C, A, and B. I'm trying to find the length of side C. You guessed it. We're doing the law of cosines. C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. Once again, please notice I have labeled my diagram. You get to pick how you label. I've labeled my diagram, so this is the same formula we've been using applies here as well. I know the measure of angle C. I'm trying to find the length of side C, right? And I know A, I know B, right? Label your diagram so that this formula works. Okay, great, here we go. It's time to plug and chug. C squared is going to be equal to 15 squared plus 36 squared minus 2 times 15 times 36 times the cosine of 115 degrees. Okay, awesome, here we go. 15 squared is 225. 36 squared is 1,296 minus, I'm going to take the cosine of 115, it's going to be a negative number. Multiply by 36, multiply by 15, multiply by 2. Do not lose any of those decimals. You get negative 456.4277277. Awesome. Add the opposite. You add all of those guys together. In fact, let me put that in there. Add the opposite. And you wind up with 1,977. Again, do not lose any of those decimals. 42773. Take the square root of both sides. And C is equal to 44.468 miles. All right, here's what you just did. You just found, right, how far is the distance between the patrol boat and the fishing boat when the distress signal goes out. They are 44.468 miles apart. Careful, the question asked you how long. Let me go back. How long will it take the patrol boat to reach the fishing boat if it's traveling at a speed of 12 knots? Well, no problem. I now have a distance and I have a speed. 12 knots. You guys should remember a great little formula from physics back in middle school where the speed is equal to the distance divided by the time. However, right, I'm trying to solve for time. How long? So we'll multiply the t to this side to get the t by itself, divide by s, and so you wind up with t is equal to the distance divided by the speed. T is equal to, my distance is 44.468 miles divided by 12 knots, and t comes out to be 3.7 hours. So, how long will it take the patrol boat to get to the fishing boat after receiving the distress signal? It'll take it 3.7 hours to travel that 44.468 miles that are now between those two vessels. And that is the law of cosines working its magic on a non-right triangle, right? We've got here ourselves a triangle here that has no right angles in it. We're trying to solve for the length of a side and then use that information to give us something about either the speed or the time or something like that. Anyway, the point is this, you just solved a really, really awesome problem, and it was the law of cosines that helped you do it. Head on over to the next page of the notes. We'll take a look at a couple more problems and how the law of cosines will help us solve those. I'll meet you there.